rate of reaction. It may be a reversible reaction, may be an irreversible reaction. And what means by this rate of reaction? We can we define it as the change in the amount of a substance per unit time. And we define the rate of reaction in this way. And then the amount we can represent it by using the amount of the reactants or the products. And for the time, you just need to measure the time. And for the measurement of the time, it's just very easy by using a stopwatch, and then you can measure it. And however, for the amount, we have several ways to measure the amount. And the main idea is that we have to ensure that the amount for the parameter that we would like to measure, they are directly proportional. 我哋咧點樣可以知道一嚿嘢咧佢嗰個嘅數量係啲咩咧？我哋要有啲嘅 parameter， 即係一啲嘅參數啊。參數係啲咩？我哋可以量度到嘅嘢嚟嘅。而佢哋咧要同嗰個嘅 number of moles 啦，或者嗰個 weight 啦，總之個 amount 即係佢成正比咧，我哋就可以用得佢啦嚇。So for starting this lesson, I would like to introduce several methods for monitoring the amount of the reagents. It can be the reactants or the products. And if you represent the rate of reaction in terms of the change in amount of the reactants, and you will got a negative result if you just directly put it into the equation. It's because for the reactant is always reacting, of course, its amount will be decreased in the process. And if you are measuring the rate of reaction in terms of the amount of product, then you will observe a positive relationship. It's because as the reaction proceeds, then the amount of product must increases. But for the first two parameters that we can reflect the amount of the reagent is that we can apply this PV equal to nRT, and we call it the ideal gas law. And it is applicable for all the gas system, but not for solid, not for liquid. So if you refer to this equation, we can do several things. First of all, we can keep T constant and then P constant. And then R, we call it gas constant, is always a constant. So after resetting these three parameter constant value, you can observe that the final result is the volume of a gas is directly proportional to the number of moles of it. And the number of moles is actually the amount of it, so they are directly proportional. 咁識中間呢個 sign 係嘛？識唔識㗎？中間呢個類似 alpha 嘅東東。咁啊呢個 sign 解 directly proportional 喎。咩事？唔知你有冇學啊？咁即係你學 variation 嗰課咧。你可以將佢寫做V 等於 Kn 咧嗰個 concept 嚟啦。Oh, and after you simplify this ideal gas law into this simple version that the volume of a gas is directly proportional to the number of moles of it is another law. We call it Avogadro's law. 咁啊，同個 Avogadro's number 嗰個之前嗰個名佢一模一樣㗎。咁但係佢變咗做條 law 嘅時候咧，就講緊呢一個 relationship 啦。Number of moles equal to volume divided by volume. And I just changed the subject of the equation a little bit. It's because if you remember, we can link it to so many equations. Say, for example, if we change the number of moles as a subject, it will be equal to volume over molar volume. And then it can be equal to mass divided by molar mass, and then it can be equal to mv and all etc. equation you can use in number of moles calculation. 咁啊就係話點解我要寫成呢個 form 嗰個嘅好處嚟啦嚇。Oh, and then for molar volume of the gas in this case, it is this value at 180 m and then 298 K, and it is well known as the room temperature and pressure. It is equal to 2040 m cube, or is equal to 24000 cm cube, and it is applicable for all the gases. And unlike the solids, different substances they have different molar mass. For all the gases, they occupy the same volume as long as their pressure and then the temperature they are the same. 咁無論我係1 mol 嘅oxygen 啦、O2 gas 啦、1 mol 嘅 nitrogen gas 又好啦、1 mol 嘅 methane gas 又好啦，全部總之佢係1 mol 嘅咧，就 occupy 嘅 volume 都係而家呢一個數值啦。Oh, and for the calculation of this part, it's just very easy, putting those numbers into the equation and then you can get the answer. And for example 1, for this 30 cm cube of CO2, and this should be the volume data. And then because now you are using cm cube as the unit, so when you are applying the equation, the molar volume of it, we have to use this 24000 cm cube. And then you can get the answer 30除翻24000啦。And sometimes the mole will have a unit like this. And do you understand how to do this kind of calculation? Oh, if you understand, just try the second example. 第二隻 gas 係咪 C2H6 啦？總之佢係 gas 咧，你就可以用得呢條 equation 㗎啦。咁所以如果你之後遇到啲 reactants product 係 gas 嘅話咧，其實你只要 measure 佢個 volume 咧，你就好快知道佢 number of mole，唔使再慢慢磅佢咁樣啦。What do you got the answer? What's the answer? 0.2, thank you. And the corresponding equation is just 4,800. Put it onto the top, the volume part, and then divide it by the molar volume of a gas. 咁應該篤機就計到出嚟㗎啦。Oh, can you handle it? Oh, and then the other thing is that how can we measure the molar volume by an experiment? And you just study this setting first, and then think of the principle behind. And I can give you several hints. For this case, the magnesium, it is the limiting reagent. And then for the acid, it should be in excess. And then maybe give you several seconds to think of the principle behind. Or can someone tell me the principle behind why we can use this setup to measure the molar volume of the gas? What's the gas formed between magnesium and the acid or hydrogen? And then for all the hydrogen, they will go inside another measuring cylinder. Is it okay? And then this measuring cylinder is placed invertedly so that the hydrogen it will rise to the top, and then you can measure the volume of hydrogen inside the measuring cylinder. Oh, and then what else data do you need for calculating the molar volume of hydrogen? What else information do you need according to the equation above? 而家我度到嗰個 volume of hydrogen 啦，係嘛？我要計個 molar volume 啦，爭啲咩 term 啊 ？Number 9。OK，個 number of moles 要知道啦，得唔得？ And then how can we find out the number of moles? It's just very easy by using the limiting reagent, and then you can get the result. And in the setting of the experiment, the magnesium ribbon have to be sent first. And this in order to remove the oxide layer onto the top. Otherwise, for that 5.7 gram measure, it may contain some magnesium oxide inside. So that at the beginning, we have to remove the oxide layer by using a sandpaper, and then we put it inside a conical flask, and then with some excess acid, and then the number of moles of hydrogen generated can be calculated easily. So after this, you can measure the volume of hydrogen, and then you put it inside the equation above, and you can got the molar volume data already. Can you see the whole principle of the setup? Oh, and in the process, you better ensure that it is undergoing under room temperature and pressure. Although the reaction between metal and then the acid, it should be exothermic. However, on another side, for the hydrogen side, you can keep that is under room condition to ensure that this value obtained should be the same. 咁如果你記得上面係用 PV 對 nRT 㗎嘛，我要 establish 咧 molar volume 呢個 concept 嘅話咧，一定要 P 同埋嗰個 temperature 佢都係 constant 先至可以做得㗎嘛，係嘛？咁你如果唔係佢出嚟個數值就會唔同咗㗎啦。Oh, and then for boy, I think I told you already, is used to remove the oxide layer. And be reminded that when you are using the mass divided by molar mass, you need a pure reagent. If there are some magnesium oxide onto the top, then you cannot apply the equation mass divided by molar mass. Oh, and if you understand, you just finish C and D part yourself first. I think you can handle the calculation. Oh, and the equation look like this. And for this case, because hydrochloric acid is in excess, so we do not need to consider its number of moles, just mg. And in case you forgot how to do the mole calculation, just write down all the number you get below the species. So for mg, you should apply mass divided by molar mass. And then in this case, number of moles, I mean the mole ratio between mg and H2 just equal to 1 to 1. So it's also equal to the moles of hydrogen gas. And then you have to use the relationship you learned today before, just the number of moles of hydrogen equal to volume divided by molar volume, and then that's the answer.咁就應該計完啦。試下讀一次先，等等啊。咁啊24000啦。得唔得？成個計法。咁啊，記住啊，呢度入邊係全部 gas 個 occupy 個 volume 都係咁樣嘅。咁所以咧，如果咧之前咧你諗緊啲 gas 嗰個 density 嘅時候咧，你可以點樣比較咧？就係話咧 density 係啲咩 ？density 就係話 mass over volume 啦，係嘛？咁既然咧每一隻 gas 咧，佢嘅嗰個 occupy 你嘅 volume 啦 ，ideally 嚟講咧，佢哋全部都一樣噶嘛。咁所以咧，佢哋其實如果係 gas 嘅話，佢哋個 density 咧 就 directly proportional to the mass of it. So that you can just compare their molar mass of it, and then you can compare the relative density. So say, for example, if you want to compare oxygen and then CO2, which of them has a higher density? And then you just calculate their molar mass of it. And for oxygen, it should be 32.0. And then for CO2, its molar mass is 44.0, and is their molar mass. And because their mass is directly proportional to their density, so you can say that CO2 is denser than oxygen. Can you see the idea? And that's why you can use the fire extinguisher to displace oxygen from the environment and then to stop the fire. Oh, if okay, then more examples on the mole calculation part. Or maybe I directly do this equation for you, is because it is a little bit easy. And it is also a special technique when you are given some volume of gases.咁就咁呢條 equation 其實都好多嘢可以講得啦嚇。First of all, you can look into the details that how can the product be formed. How can it be formed? 中間個過程其實發生緊咩事啊？我如果畫出嚟嘅話啦。What's happening in between? How can the ammonium ion form? 點解可以 form 到嗰個 product 嘅？第一步做緊啲咩 ？Which which bond is broken and which bond is forming? Broken first. What bond is broken? 咁咪又同我打咗啦嚇，咁啊 HBr 嘅 single bond is broken 啦。So the one indicated in blue for HBr is broken first, is a process. And then secondly, for the N, because it has a lone pair of it, and after the broken of this HBr, what's formed is Br minus and then H plus part. And for the H plus part, it is highly unstable because it has no electron at all and it does not obey octet rule. So that for the N, it can form a dative covalent bond with the hydrogen ion. So that is the whole case. First of all, the bond broken should be HBr. And then bond forming, it should be the dative bond. From the ammonia to the hydrogen ion. So if you really draw out the enthalpy diagram and the energy profile of it, do you remember this diagram? Reaction coordinate. It somehow look like this. For NH3 and HBr, it should be the reactant. And then you can see that in the whole process, there is a bond formation and bond broken. I don't know whether it's exothermic or endothermic, just randomly pick a stage for the product side. And then at the top part of it, the species look like this. And for the top, it means that there are some partial bonding. 咁話就話佢個過程就係佢拆開咗啦，跟住佢再 form 翻啲 dative covalent bond 啫。咁但係如果係真係喺個世界入邊咧，佢兩個過程基本上佢同一時間做緊㗎啦。 咁記住喎，呢一個咁嘅狀態咧，佢係最唔 stable 嗰個狀態嚟嘅喎。咁所以我哋就會話佢嗰個嘅 energy level 就係最高啦。喺 Cam 入邊嘅世界就係話咩叫做穩定咧？越低能就越穩定，得唔得？佢嘅 energy level if it is lower, then it should be more stable. And on the contrary, for this species is highly unstable, then of course its energy level should be the highest. So if okay, then go back to this question, how to deal with the mole calculation in this question. Oh, and maybe I'll write down the answer for you first. And I can actually skip so many steps in the mole calculation to obtain this answer. Do you know why? It's just the difference between 60 and then 45. 連計數機都唔使用，雖然你可以用嘅減數都可以用計數機嘅。背後嘅原理係點？點解我可以直接將佢兩個相減就知道答案嘅？And I can write down you some more steps. And I can skip all the mole calculation actually. Why can I establish this first step？ 點解我可以直接寫得嘅？我背後其實做咗 mole calculation 嘅喎，點解 work 嘅？They have the same ratio. What means by the same ratio? Same 嘅咩嘢嘅 ratio 啊？佢嘅比例一樣啱啦。今次佢哋嘅咩比例一樣？平時我哋計 mole 嘅時候就用 mole ratio 啦。OK，thank you。咁啊，平時我哋用就用 mole ratio 搞掂啦。咁但係今次因為咧，我哋個 molar volume 係一樣啦，係嘛？咁我哋可以直接咧將個 mole ratio 咧直接 equal to 個 volume 嘅 ratio for them to react. So that in this case, because their mole ratio is 1:1, it means that the volume ratio of them to react is also 1:1. So if you have 45 cm cube of MX3, then of course 45 cm cube of HBr is littered. 得唔得？其實你中間做咗嗰個 mole calculation 㗎啦。不過今次就因為 mole ratio 等於 volume ratio，你直接 take 佢個 volume ratio 就已經搞得掂。咁就係最快捷做呢條嘅方法嚟啦。If you understand, then just the one below. Try to apply the same technique using the volume ratio instead of mole ratio in your calculation. And it can make your calculation much faster if the reactants are gases. And if you really understand the idea of volume ratio equal to mole ratio, then I think you got the answer already. Even do not need your calculator, I think. 因為啲數實在太靚仔啦，所以唔使用計數機都 suppose 可以計到出嚟呢個。好，唔該，見唔見到？咁啊，如果我 show 你睇兩個方法嚟做啦，雖然你哋明嘅話，直接用個快速方法就搞掂啦，係嘛 ？Because now in the question is given that some oxygen remain unreacted, and it means that the C2H4 is limiting. And then for the all species involved here in the question, they are all gases in nature. So that when 100 cm cube of C2H4 reacted, then 300 cm cube of oxygen is littered, and then of course 200 cm crib of CO2 they are formed in the process. It's because the mole ratio equal to the volume ratio already. 咁你直接 apply 個 relationship 其實已經搞得掂啦，係嘛 ？Because 其實將啲都係變翻文字啫，係嘛 ？Because C2H4 is limiting, so when their mole ratio is 1 to 3 to 2, then 跟住寫埋個答案咯，咁咪完啦，係嘛？ Oh, and then finally, you just need one more step to calculate the volume of oxygen remain. Originally, given that there are 400 cm crib, and then now 300 cm crib is used, so 100 of it is left behind. And there's the whole idea. 有冇唔明呢個點做啊？嗱，唔明嘅話，我哋用翻中四嘅idea， 點樣可以逐步好慢咁樣計條數出嚟？咁啊慢得嚟一定啱嘅，係嘛？咁我淨係計 CO2 嗰個你睇算啦嚇。And then the mole ratio is times 2 divided by 1. And then finally, because you got the number of moles of CO2, and then you just need to multiply by the molar volume, and then you can got the volume of CO2. And then I think you can see the relationship behind. Why I said that you have a much better way of taking the volume ratio directly is because in the process, the molar volume, it can be cancelled out. 咁所以你用嗰個 volume ratio 直接嚟計數，其實就會更加快啦，係嘛？咁就中間嗰個，如果你用翻之前嗰啲方法演繹嘅話，呢個頭先諗嗰些嘢點解 work 嗰個原因嚟啦。Oxygen 我唔計啦，下跌去剩幾多嗰個。Oh, and up to this moment, you learn two things already. First of all, is about the molar volume calculation, and you know that the volume of a gas can reflect its number of moles, so that we can use it in the monitoring the rate of reaction by using the measuring the volume over time, and then we can got the answer. Rate 係啲咩？就係話我要知道一嚿嘢佢隨住時間佢嗰個嘅 amount 嘅改變係啲咩啊嘛。咁 volume 就其中一個可以用嚟反映佢數量嘅方法嚟嘅，咁就第一個 concept 啦。Oh, and then similarly, if you apply the same equation, PV equal to nRT, it is secondly how we can monitor the amount of a substance. And this time we keep the volume of the container the same. And then we also keep the temperature of the system constant, and then R is a gas constant, is always a constant. And then you can establish another directly proportional relationship. And the second parameter to reflect the number of moles is the pressure of a gas. 咁所以第二個我哋知道咧，啲 rate of reaction 佢快慢嘅方法係啲咩？就係我哋喺一個咧唔係elastic啦 closed 嘅 container 入邊咧，我度住佢行 reaction 嘅時候，每一個時刻嘅 pressure 嘅改變。Say for example, if in a reaction there is a gas formation, and then in a fixed container, then pressure will build up, so that you can just measure the pressure, and then it's changed over time, and then you can got the rate of reaction of this process. And on the contrary, if some gas is consumed in the process, then you can use the pressure drop over time to describe the rate of reaction. Can you see the idea? Oh, and then the third parameter we can use is about color. And I think you'll know this term in the 2 DSE past paper already. In one of the questions, it asks how can we use instrumentation to measure the color intensity. And the color intensity can be measured by this colorimeter. Color 好明顯啦，度顏色嘅嘢啦。meter 係啲咩一個計咯，用嚟例如 pH meter 度咩咪度 pH 咯，colorimeter 度咩就度顏色嘅深淺程度啦，得唔得？中文叫咩？中文叫做比色計。And the idea is just very easy. For a concentrated solution, it should be with a higher color intensity. And on the contrary, if it's dilute, then its color will become paler, its color intensity will be lower. And this is the concept behind. And then if you really establish a relationship, it look like this. A equal to ABC. For each of these parameters, it look like this. For C, it is the concentration. Oh, and then A, it is a constant, depends on the reagent. And as you may know, for different species, although they may be also in maybe blue in color, however, there are deep blue, pale blue, and etc. And also for maybe green. Fe2 plus, we say that is pale green in color. However, for Leco 2 plus or Chromium 3 plus, we describe that as green in color. 咁點解我哋平時描述嘅時候有呢啲 term 就係會影響到呢個 A 呢一個嘅 constant 啦。Okay, and then for boy is the width of the container. 咁如果你記得嘅話，我應該 show 過你睇呢啲玻璃咧，咪話你平時望入去咧，你咪好似 colourless 咁樣嘅。但係喺條邊度望入去咧，佢咪綠色噶嘛，係嘛？就話佢光穿過嗰個嘅長度越長咧，其實就越多光咧俾人 absorb 咗。佢睇出嚟個 colour intensity 咧就會越深色嘅。Finally is the parameter we measure is capital letter A and we call it absorbance. And this is the amount of light being absorbed in the process, absorbance. I show you an animation first. 咁頭先嗰條 law 有個名嘅，即係 A 等於 ABC 咧，佢深啲嘅 version 咧就唔係 A equal to ABC 啦，佢係 A 等於我一陣寫俾你啦，一個希臘文字好似 E 咁嘅符號 epsilon 啦，跟住乘 L 啦，再乘翻 C 啦。咁啊，不過 DSE 入邊用嗰個 ABC 喎就搞掂啦。咁啊，嗰條 law 咧叫做Limber-Beer's law。Oh, and this is a setting about a colorimeter. First of all, there is a light source, and usually we just use white light with a color filter in this part. And then we just adjust it. Say, for example, if this is a purple solution, why is it in purple? What color of light does it absorb? I mean the solution. 吸咩色啊？It absorb the green light, green part of the lights. So here is the idea. So that when you are choosing the light filter or the light source, we have to make it green in color. And then say, for example, in this case, the absorbance is 0.2. Oh, let's see if I change the width of the container. 嗱，我將佢變厚啲啦，中間呢個，你睇下咯。What happened to the absorbance？ 吸得多咗定吸得少咗嗰隻光？即係呢個啦，原本窄啲啦，最窄啦，係嘛？0.1啦，係嘛 ？absorbance 佢吸咗幾多光就0.1啦。And then when we make the distance, the light travel longer, then its absorbance increases. So will it become darker or paler? 咁佢會越深色咯，係嘛？總之佢越吸得多光，佢嘅 absorbance of that light is higher, so that it will become darker in that case. Is it okay? So let's see another variable of it. I think you can observe it yourself. And to be a fair test in each of the case, use the same width of the container. And this time I changed the concentration of the solution below. And now it is 100 mu m. Mu means 1 times 10 to the power negative 6. And I now make the concentration become higher. And you see the effects of it on the absorbance. Can you see the effect of it? 呢個低 concentration 咧 ，and then with a higher concentration。咁見到埋第二個 relationship 啦，係嘛？頭先第一個就 show 緊你睇咧 ，absorbance will increase with the increase in the width of the container, and then now it's directly proportional to the concentration of it。咁就頭先嗰個嘅點樣做實驗做出嚟啦。好，咁啊第三個咯，就話點解我哋需要揀個 colour filter 嘅原因係啲咩啦？So let me lower the absorbance test。嗱，咁啊睇下啦喎，如果我哋揀錯咗色咧，有啲咩問題啦？ And now I choose a correct color. Yes, because for a purple solution, it absorbs the green light, so that we can see a quite obvious change in absorbance. Oh, and let's see, what if I now using a purple light to shine on it, and then I now change the concentration again. Well, it may still show some change in the absorbance. However, what's the problem? Do you think it's accurate if I use a purple light when measuring the absorbance? 咁唔係啊，係嘛？一定唔準啊，係嘛？如果我揀錯咗顏色嘅，佢基本上佢可能有 absorb 到啦嚇，咁但係佢 absorb 得唔多，你出嚟個 result 得0點幾嘅改變啫，係嘛？就算我整到佢咁 concentrated 都好，咁你成個 result 就會因為啲讀數太細而完全唔準確㗎啦，咁得。So that you have to choose a suitable wavelength of light. And say, for example, if you is a purple solution, then you choose a green filter. And if you are using a blue solution, then you will have to choose somehow orange or red in color for measuring the absorbance. 佢哋嘅對色啦，你要識得揀啦。By the animation for the proportional relationship between absorbance and then for concentration and the width of container respectively, and it based on the principle that a color species absorb light with a certain wavelength. 咁啊頭先就話佢係咩色啦，咁啊但係喺 physics 入邊點樣可以表達佢係咩色表達得好啲啊？咁就係用 wavelength 呢個 concept 啦，佢嘅波長係幾多？ And if its wavelength is shorter, then it will go to the purple side. And if it become longer, then it will go to the red side. Oh, and after that certain wavelength of light is absorbed, then the complementary color of it is shown. Complementary color of the light is shown. So you can use the color chart below. Say, for example, if it is a blue solution, then it should absorb the yellow light. Okay. And if it's a green solution, then it will absorb a purple light and etc. I think you learned it in Form 3. Oh, and then you can see the internal structure of a normal colorimeter, and it is different from the animation shown below. And normally we just use a light source, just a light bulb emitting some white light, and then we use a slit and then the convex lens to focus the light. And then the next part of it is the light filter, and is what you have to select it correctly. And then after this, we call it a cell. And usually the width of the cell is 1 cm times 1 cm for the base area. It's because the length of the light travel through will also affect the absorbance. So that each time we perform this experiment, we have to ensure that this should be a control variable. I mean the size of the container, the size of the cell. And the material used here is usually glass. It's because for the glass, it is more likely to be transparent. It means that it will not absorb any light at all. And we will just pour some solution inside. And finally, after the light coming out, there is a data locker, which receives the light signal, and then it will turn the light signal into electrical signal. And then you can monitor it by maybe a computer. And this is how it works. And let's try an example. For Cu NH342+. How can it be formed? Long time before learning. How can you form these cis complex ion? Okay, thank you. Someone answered in the chat box already. 咁我唔記得嘅話就係 excess 嘅 ammonia、excess aqueous ammonia 啦，記唔記得？加完之後會有 blue precipitate 啦 ，and then if you add further the NH3 into the solution, it will redissolve. The blue precipitate will dissolve to form a deep blue solution, and this is the idea how it can be formed. And then it absorbs orange region strongly, and finally it will show you a deep blue color. 咁啊，吸橙色光啊！咁如果你睇翻上面嗰個 chart 咧，橙色光即係咩色咧？橙色即係黃色同埋紅色交界呢一個位啦，係嘛？呢個位。咁結果佢相對應嘅顏色咪呢啲位咯，係嘛？係咪？所以佢就係藍藍地色啦。咁佢吸得越多呢啲橙色光，佢 show 出嚟就越藍色啦。So when you are really performing the colorimeter experiment of this solution, then you have to choose an orange filter, which only allow orange light to pass through. So that finally, when you have a photocell, when you have a light sensor, you can get a more accurate reading. And then the major concept here is that the absorbance is directly proportional to concentration. So when you are monitoring the range of reaction, you can use the absorbance of a colored solution to reflect its amount. 咁所以你如果做嗰啲嘅時候點樣度？一路擺部機喺度度住嗰個 solution 咧，由佢一路 react 啦，係嘛？跟住你一路咧計住時佢啦，睇下每個例如1秒之後咧，佢個讀數嘅改變係幾多？ and the final parameter you can measure for rate monitoring is to measure the mass. 咁透過個 mass of 一個 system 嘅改變啦，嚟睇下個 rate of reaction 係點樣樣啦，得唔得？咁就不過一路計住時間啦嚇。And just very easy, use maybe the reaction of Mg, and then with oxygen in the air. And then how you can obtain the result is that you just put it on a balance, and then it will react with the oxygen in the atmosphere, and then the balance reading, of course, it will increase as time passes. And then you have the amount reflected by the mass of the magnesium and magnesium oxide, and then you have the time data by using maybe a stopwatch. and then you can calculate the rate of reaction in this way. Is it okay? 好咁啊 ，summary 咯，今堂講嘅嘢啦嚇。咁啊，今堂最緊要就學咧，留下呢條 equation 啫係嘛 ？rate 係啲咩嘢嚟？就話總之你度到時間，度到一嚿嘢佢嗰個嘅數量，你就可以計到佢個 rate of reaction 係啲咩啦。咁啊 time 就用 stopwatch 嚟度佢啫係嘛？咁問題就係話你嗰個嘅 amount 咧用啲咩方法嚟表達？咁我哋學咗四樣嘢，四個 physical parameter we can measure to reflect the amount of a substance. That is namely the volume, pressure, and it is applicable for gases only. It is because the relationship is derived from the ideal gas law. So therefore, these two parameters, you can measure them for a gas, but not a solid or a liquid reactant or a product. Oh, and then the third parameter is for a solution. And we can use absorbance to reflect its amount. 咁啊，記住一定要喺一個 solution 你先至可以用得 absorbance 啊！你 pure substance 入邊你唔可以用佢㗎。你 pure substance 入邊你何來講到濃度咧？係嘛 ？It's because if you study the equation of it, A equal to ABC, is directly proportional to the molarity of the substance. So that if you do not have a solution, then you cannot calculate. Oh, and then the final parameter you can measure is about the mass. And because you are using the mass divided by molar mass, you are using this concept so that you must applying it on a pure substance. If you have an impure sample, then you cannot use it. 咁得。咁你可能會問啦，頭先 Mg 同 MgO 個 case 明明係一個 mixture 嚟喎，咁點解用得？就係話你 measure 緊個 mass increase 其實係啲咩嚟咧 ？mass increase 其實係個 oxygen absorbed from the environment 啫，你 reflect 嘅嗰一個嘅 mass 改變嚟啦。